This is a LeetCode problem number 1498. And in this problem, we're given an array of integers. Okay, so we can see here, for example, here is an array of integers and nums and an integer target. Let's see what is our target. Our target here is 9. And we need to return a non-empty subsequence of nums. These are the nums, this array, such that the sum of the minimum and the maximum element on it is less or equal to target. Okay, so what is a subsequence first? A subsequence could be here 3, could be 3 and 5, could be also 3 and 6. These are all subsequence. Note that in this subsequence, we didn't include, so it's 5 here. We didn't include a middle element, which means that the subsequence do not need to contain, they didn't say it, do not need to contain all items in between. We can take some left index and some right index, and that's it. Don't include the middle items. So what is basically the question? The question is that they want us to find the number, okay? They do not want us to find the actual subsequence, just the number of non-empty subsequences, so we cannot return this empty subsequence of nums such that the sum of the minimum and maximum element is less or equal to the target. And there is some technicality here, they want us to model it. Okay, so let's look at this example. In this example, we have 3, 5, 6, 7 as the input array, and the target is 9. So they say that the sum of the minimum and the maximum of the items in the subsequence should be less or equal than 9. So let's look which subsequences can we have. 3 is a subsequence. Is it less or equal than 1, the 9? Yes, the sum, because this is also both the minimum item and also the maximum item 3, because we just took 3. So it's 3 plus 3. So actually the sum is 3 as minimum plus 3 as maximum, which is 6. Okay, 3 plus 5. The minimum is 3 and the maximum is 5. 3 plus 5 is 8, which is less than the target, which is 9. Okay, so let's continue. 3, 5, and 6. Okay, this is obviously bigger than 9. So up to now we have 1 and 2 items. 5 is both the minimum and the maximum. Is it less than 5? Yes. 9, no, because 5 plus 5 is 10. Okay, so up to now we have only a 2. So let's do a jump. 3, and we'll jump through the middle element 5 and take the next number, which is 6. So 3 plus 6 is exactly 9. It's okay, it's less or equal. So here we have our second solution. First solution, first, second, and third solution. Okay, so let's have another solution. Another solution could be actually this 3, 5, and 6. What is the minimum? 3. What is the maximum? 6. So it's actually, oh, we went on a pitfall. It's actually 9. So we can take this 3, 5, and 6. Okay, because they are looking only at the minimum and the maximum elements. Okay, so we have here the fourth one. Okay, so there are 4 subsequences. Let's look at another example. Now the target is, okay, so it's pretty similar. Now let's discuss the solution without actually writing the code. So to solve this, what we can do is have a left pointer pointing to here. This would be the left pointer. The right pointer would be pointing to the latest item. So the left pointer is pointing to 0. The right pointer is pointing to the length -1. And now we check the minimum and the maximum. We know them. The left pointer is the minimum, the right pointer is the maximum. If we sort it, we can just begin the solution by sorting the array if it's not sorted. So this is called a sliding window. When we have a left pointer and a right pointer, then in programming interviews, it is called a sliding interview. So we look at the left pointer, it's currently pointing to the first element from the list 3, 5, 6, 7, which is 3. The right pointer is pointing to 7. So there is nothing to do because we already see that 3 plus 7, the minimum and the maximum, which are pointed by the left pointer and the right pointer, are bigger than the target. So in this case, where we are, the minimum and the maximum are bigger than target, all we need to do is to move the right pointer to the left. If it was smaller than target or equal, we would move the left. But in this case, we have 7 plus 3, which are together 10, which are larger than the 9. So we are going to move the right pointer to the left. So let's actually move it. Here, we move it one step to the left. And now our pointers are pointing to 3, 5, 6. Before they were pointing to 3, 5, 6, 7, where the left pointer would point to the left item of 3, the right pointer would pointing to the right item, which was 7. And now, since the item before 7 was 6, and we move the right pointer one step to the left, now the minimum is 3, and the maximum is 6. 3 plus 6, great, it's less or equal. What are we going to do in this case? We can know how many items we have between the right and the left. We know we have 3 items. And we know we can either include 5 or exclude 5. And if we had even 100 numbers in between the left pointer and the right pointer, we could include and exclude each of them. And if we can include or exclude 5 numbers, how many combinations do we have? 2 to the power of 5. Okay, so in this case, we are using a small pattern in interviews of calculating the number of items that we can have. So let's calculate how many items can we have that would satisfy the minimum 3 and the maximum 6. Okay, so we know we can include or exclude any of the items here. We for sure take the minimum. Okay, the minimum we for sure take, which is pointed by the left item. And then all the rest of the items, other than the left pointer, we can include or exclude. How many items do we have to the right of the left pointer? We have right minus L. Let's see, if this was index 0, first was index 0, second was index 1, and the last one pointed by the right pointer was index 2, then 2 minus 0 is 2, which is exactly these 2 items. So this should be in the exponent, and we can include and exclude each of them. 2 to the power of right minus left. This is the number of combinations that we can have by this. Now you may ask, but what about the option of only 3? We included it because 2 to the power of something is all the combinations that we have in 2 to the power of 2, all the combinations including the empty list. And if we get here the empty list for 5 and 6, here we get the empty list, then this would include only this option. So it's enough to say that the number of combinations of these 3 items, which we know the left item is satisfying the minimal one, and the right item plus the minimal one from the left side is satisfying less or equal than the target, then we can know that all the combinations are 2 to the power of right minus left. And now that we have it, what we can do is we said that this satisfies the combination. We know all the combination. And now what we're going to do is move the left pointer to the right because we have satisfied the combination of target. Now let's see if we have another combination. So we move the left pointer now to the right and do this check again. The minimal item now is 5, not 3. And the maximal item is 6. 5 plus 6, nothing happens. Okay, it's bigger. and then 9. It's 11. And what do we do when the 5 plus 6, the left pointer and the right pointing items are bigger than the target? We move the right pointer to the left in order to get a smaller item. So let's move it to the right, to the left. Okay, let's try again to move it to the left. Okay, now we move it to the left. Now both the right pointer and the left pointer are pointing to the same item, which is 5. Okay, so now is 5 plus 5 as the minimum and the maximum larger than 9? Yes, it is 10. And what do we do when we are larger than target? We move the right pointer to the left in order to get smaller number. Let's move it to the left in order to get smaller number. We move the right pointer to here, but then our if condition, our basic if condition inside the program would say something like this, while, which is a very common pattern for sliding windows and for programming interviews and for left and right pointers. While left pointer is less or equal than right pointer. So we would exit this main loop where we calculated the actual result, and now we would just return the result. Okay, so this was a brief overview to the problem of 104.1498, where we needed to calculate how many combinations do we have, how many subsequences do we have. Subsequences hints us that we need combinations. We have an array. Because we have an array, this means we can have a left and a right pointer and the sliding window. And we can always check the left if we are smaller currently with the min and the max than the target number, then we move the left pointer to the right, and we are higher than the target, we move the right pointer to the left. So I hope this cleared up. Once we understand this, the code is pretty self-explanatory, and see you guys next time.